going to look at lesson 3.7, graphing absolute value functions. Now, so far in this chapter, we have graphed linear functions. What do linear functions look like when we graph them? Lines. Very good. So all of that changes today because an absolute value function is a V shape. And you can see in your notes, I gave you a little graph, and you can see that it is V-shaped. So the essential question, how do the values a, h, and k affect the graph of the absolute value function g of x equals a times the absolute value of x minus h plus k? Now, if you haven't picked up on this yet, what they are going to ask us to do today is talk about transformations like we did yesterday, all right? But transformations done to an absolute value graph. Now, let's review absolute values for a second. The absolute value of any number is what? Positive. Very good. And what does an absolute value problem look like? What does an absolute value problem have in it that makes it very obviously an absolute value problem? These. The bars. Very good. All right, you can see in the essential question, these absolute value bars, okay, make it an absolute value problem. So look at the definition of an absolute value function. It's a function that contains an absolute value expression. So it's going to have these absolute value bars, okay? Vertex. Now this is a geometry word that you may or may not have heard before, but this is the point where the graph changes direction. Since our graph is going to be V-shaped, as you see in the little example, as I follow this graph to the left, it's going down, but then all of a sudden it hits a point and it changes direction and it starts going up. So here's what I want you to do on that little graph I gave you. I want you to plot a little point at the bottom, and then I want you to write vertex. Okay, that is the vertex. So when I ask you in a little bit to make sure you graph the vertex, it's that point where the graph changes directions. Now, we're going to graph. Example number 1. It says graph the parent function f of x equals the absolute value of x. And you see the word Desmos. Okay, this is the point where I'm going to introduce you to a graphing tool. We don't use graphing calculators in here, but we are going to learn how to use the graphing tool, Desmos. So I need you to take your phones out of your pocket, and I'm going to give you one of two options. Number 1, you can go to your app store, and there is a Desmos app. Okay, it's green, it looks like graphing, it should be very obvious. If you say, Miss Johnson, my parents said I cannot put any apps on my phone, or I ought to get their permission first, that's okay, because you can also get to Desmos through a website. If you are in your browser, it could be Google, it could be Safari, but once you're in your browser on your phone, if you go to desmos.com, and you hit enter, it's going to take you to this page, and you're going to hit the button that says start graphing. But this is Desmos. So whether you're there through the internet or you are there on the app, this is what you should be looking at. Now, when you're in Desmos, you have a couple of options. All right. The problem that they've asked us to graph is f of x equals the absolute value of x. Now, what's another variable that we could use in place of f of x? Y. So Desmos does recognize y or f of x. If you do f of x, just be very careful and make sure you're actually putting the x in parentheses, and then it equals. Now, you have this little keyboard button on Desmos. If you hit it, this is where all of your symbols are going to come up. And you can see the absolute value symbol is right here. So we would insert the x, and then if you hit enter, it will close the absolute value bar for you. But do you see Desmos has now graphed for you? Now here's what you have to do. You have to take that graph and you have to transfer it onto your paper. You say, okay, that seems simple enough. It does, except for the fact that you have to transfer 3 points from this graph onto your paper. And for some reason, that tends to give people trouble. All right? You say, well, how do I pick the points? I don't care as long as you pick 3 points that are on this graph. Now, there needs to be one from each line or each side, and the vertex needs to go with you. All right? So, you've got to learn how to navigate through Desmos. You guys are going to be able to use your fingers to actually shrink or zoom in and zoom out, which is going to change what the graph is counting by. Me, I have on the internet, I have this plus or minus button, but do you see as I zoom in, how the graph begins to count by ones. I have 1 here, I have 2 here. So for me, I can see 2 very obvious points. I see 1 right here at 1, 1, and I see 1 right here at -1, 1. Now, I have the option, I can type those in just to be sure they're actually on my graph. Hit enter, and sure enough, there's the point on my graph. All right, I also think that -1, 1, but just to be safe, I'm going to test it. -1, 1, it is absolutely on my graph, and of course the vertex is right here at 0, 0. That one's pretty obvious. All right, but now I have 3 points that I can take and I can transfer onto my paper. We're going to take -1, +1, and we're going to plot a point. We're going to take 1, 1, we're going to plot a point, and I'm going to take and plot 0, 0. Now, I know it's V-shaped, so I'm going to make sure that the line stops at the vertex, but it goes through the other point because I have to put arrows on the end. Now, here's one thing you're not going to see on Desmos. If you're looking at Desmos right now, you're looking at 2 lines that are going off in either direction. You don't see an end to those lines, and you're not going to. So I don't care how long you draw those lines as long as you put arrows on the end, because that shows that it goes off in both directions forever. All right, now what have I forgotten to do? Label the points. All right, make sure we label our points. I don't want to guess what points you pulled off of Desmos. I want to see that you've labeled them. So I have 1, 1, I have 0, 0, and of course I have -1, 1. Now, somebody in the room may have picked other points. I think there was a point at -2, 2, and there was a point at +2, 2. That's great. As long as it's on the graph, I don't care what points you pick. But you have to pick points that actually fall on the graph. Look at example 2. This set of directions asks us to do 3 things. They want us to graph the function, compare it to the parent function, and then describe the domain and the range. All right, so I want you guys clear your Desmos, and now I want you to graph the new function. It's h of x equals the absolute value of x minus 1. Now, while you're doing this on Desmos, I want to talk to you about what happens if you don't have Desmos. What if you come to class one day and I say, get out your phones, we're going to use Desmos, and you say, Miss Johnson, I left my phone at home. Miss Johnson, my parents took my phone. Miss Johnson, my phone is dead. Okay? Here's what I need you to understand. You can still do this problem because you have learned how to create X and Y charts. So I'm going to create an X and a Y chart while you're using Desmos. Okay? You're graphing it in Desmos, you're transferring the points, and I'm going to show you that this problem can still be done without the luxury of Desmos. Okay? We have learned when we make an X and a Y chart that the 3 easiest X values are -1, 0, and 1. So that's the 3 numbers I would use for X. My function is h of x equals the absolute value of x minus 1. And of course my outputs or my outcomes are going to be that h of x, which can also be replaced with what letter, everyone? Y. H of x can be replaced with y. So I plug in my values. The h of x equals the absolute value of -1 minus 1. H of x equals the absolute value of 0 minus 1. And h of x equals the absolute value of +1 minus 1. Now, of course, I have to do the absolute value part first. So the absolute value of -1 is +1. 1 minus 1 is 0. The absolute value of 0 is 0. And 0 minus 1 is -1. And the absolute value of 1 is 1. And 1 minus 1 is 0. So I have just created the ordered pair -1, 0, 0, -1, and 1, 0. How many of you just got done plotting those points from Desmos? Raise your hand. Okay? There you go. So if I am without Desmos, if there is a point where I am without a phone and I cannot get to Desmos, I can still do the problem. Now, some of you may have found different points. Again, there's a lot of different points that will work. But -1, 0, 0, -1, and 1, 0 are definite points on this graph. So I would go and I would graph them. -1, 0. We said 0, -1, and 1, 0. So again, I see my vertex. I make sure that both sides stop at that vertex. draw a line through the points, and add my arrows to the end. And I would not forget to label. I've got 1, 0, negative 1, 0, and negative 1, 0. I wrote this wrong. It would actually be 0, negative 1. All right, good catch. All right, so 0, negative 1. Now, I've done the first thing they've asked me to. I have graphed the function. The next part of the directions asked me to compare. All right, I want you to highlight or underline the word compare. And here's why. Anytime you see the instructions compare to the parent function, I need you to begin to associate that with transformations. They're asking us, when they're asking us to compare, they want to know the transformations that were done. Okay? Again, half the time we can't answer a math question because we don't know what it's asking us to do. So we need to learn that when it says compare, it wants us to figure out and write down the transformations. Now, look at our function. Part of this function is the parent function. You're like, I don't understand what you're saying. Go back to example 1 and look at the directions. It said graph the parent function f of x equals the absolute value of x. So I want us to highlight the part of our problem that is the parent function. So what part of our problem is the parent function? No, h of x was not in the parent function. What is from the parent function? The absolute value of x. Remember yesterday as we were learning about transformations, we kept finding and highlighting f of x, f of x, f of x, because that was the parent function. Okay? Well, in this problem, the absolute value of x comes from or is the parent function. So we should be able to very easily see that they've done what to the parent function? Read the problem. H of x equals the absolute value of x minus 1. So guys, which transformation deals with subtracting and adding numbers? Because that's what they've done. They have subtracted 1 from our parent function. So which transformation should we be looking at on our cheat sheets? This is a translation. So let's go ahead and write down translation. We don't know which translation yet, but we will in just a minute. Because the next thing we ask, are they subtracting 1 from the entire function or just x? Now, before you answer me, remember, look at your cheat sheet. Okay, if they're doing something to just x, they, on the cheat sheet, are in the parentheses with x, right? So wouldn't it make sense if they're doing something to x in this problem that they would be in the bars with the x? So let me ask again. Are they subtracting 1 from the entire function or just the x? The entire function. They are not in the bars with the x. They're outside the bars. So this is what type of a translation? If they are subtracting 1 from the entire function, that makes this a what? That makes this a vertical translation. Now, we like verticals because they're straightforward. They're subtracting. So is that moving up or is that moving down on the y-axis? Down. And they're moving down how many units? They subtracted 1. So they are moving down 1 unit. And that is the transformation that was done to our problem. Now, one more thing the directions want. They want us to describe the domain and the range. So let's talk about domain. Which set of values does the domain represent? Got to go back a few sections. X. Okay, so let's talk about this. The arrows on either side of this V shape tell us that our lines go off to the left and off to the right forever and always. Okay, for infinity. So, are there any restrictions to what the x can be? Or can the x be any number we want it to be?
1.
It goes off in both directions forever and ever. So there's no number that x cannot be. So guess what the domain is? All real numbers. That's how easy this is. Because the arrows are there and the lines or the sides go off in both directions, this is all real numbers. Now the range is a little bit different because there is a bottom to this graph. Okay? What is the lowest y value that this graph hits? -1. Okay? And you'll notice I already wrote down the y because the range deals with the y values. So the question, are our y values greater than -1 or less than. Now this graph opens up. So if I follow the graph, the y values are getting bigger, larger, greater than. Is it just greater than, or is it greater than or equal to? The graph actually hits the -1. So we have to include it in our answer. So the range is y is greater than or equal to -1. Now let's do it again. I want everybody to go to letter B, and I want you to clear your Desmos, and I want you to graph letter B. Again, if I did not have Desmos, I could create an X and a Y chart, and I could very easily find 3 points to plot. But I'm going to wait on you guys to give me the points that you're finding on Desmos. So you guys have given me 0, 0. You've given me -1, -3, and you've given me 1, -3. So we can see the vertex this time is at the top, which means our graph opens down. So we just got to make sure we draw through the points so we can put our arrows on the end. Don't forget to label. We've got 0, 0. We've got 1, -3. And we've got -1, -3. The second thing it asks us to do is to compare our function to the parent function. So once again, tell me what part of the function came from the parent function, because we're going to highlight it. The absolute value of x. Now, be very careful when I ask you this next question. How many things have been done to this problem? How many transformations have been done to this problem? No. 2. Remember what we learned yesterday about a sign change? There is a sign change and there is a 3. And what are they doing with the 3? Are they adding it, subtracting it, or multiplying it? There's a 3 and a bar with nothing in between them. What are they doing with the 3? They are multiplying. So this is 2 separate transformations. The sign is its own transformation. What kind of transformation has a sign change? A reflection. So this is a reflection across. Now again, it's all about, have they changed the sign of the entire function or just x? No. Yes, remember, they would be in the bars with the x if they were doing it to just the x. They're outside the bars. So close, okay? They're outside the bars, so they have changed the sign of the entire function, which makes this a reflection across the what? Look at your cheat sheet. No, they've changed the sign of f of x, which is y. This is a reflection across the x-axis. Now, they're multiplying by 3. What type of transformation deals with multiplying? Look at your cheat sheet. Which type of transformation deals with multiplication? Stretches and shrinks, okay? So we know it's one of those two. The question is vertical or horizontal. Again, are they multiplying 3 by the entire function or just x? The entire function, which makes this vertical or horizontal? This is a vertical. Now we have to take that 3 and plug it into those little formulas. Is 3 greater than 1 or is 3 between 0 and 1? It's greater than 1, which makes this a vertical what?
Stretch.
A vertical stretch. Now remember, we like vertical because it's straightforward. It's by a factor of, what's the number that they're multiplying by? Be careful. It's not negative. Negative was its own transformation. Okay? A vertical stretch by a factor of 3. Listen, the factor will never be negative. All right? When you're doing stretches and shrinks, the factor will never, ever, ever be negative because the negative is its own transformation. So, there are the 2 transformations. Now, domain. What's the domain of this graph? There's arrows. The lines go off in both directions forever and always. So, it's all real numbers. And the range. What's the y value that this graph hits? It's 0, but be careful. This graph opens down. So all of my y values are greater than 0 or less than 0? Less than. Are they or equal to? Yes, because the graph actually hits 0. So there is your domain and range, and that is lesson 3.7.